This is the Daily Space for today, Thursday, June 4th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. The summer meeting of the American Astronomical Society is over, but the science rolls on and on. There's a lot going on in the world, but for now at least, we're going to focus on beyond our atmosphere. Our first story of the day taught me a new term, Fermi bubbles. Named after the gamma ray telescope that discovered them, these dramatic regions of heated gas extend above and below the disk of our Milky Way galaxy and were created during high-energy events involving our galaxy's supermassive black hole. First discovered in 2010, we're still trying to understand these structures, what formed them, and how far-reaching an effect that source event may have had. It's currently thought they most likely formed when 100,000 solar masses of material formed an accretion disk near our supermassive black hole. As the material orbited rapidly around it towards its death, it released energy that, illuminated the surrounding gas that formed these lobes. New research shared yesterday at the American Astronomical Society meeting shows that the event related to the Fermi bubble formation had much more distant effects than previously realized. Beyond energizing the Fermi bubbles, the light ionized gas as far away as the Magellanic stream, the stream of material that was pulled off the Magellanic clouds to nearby galaxies as these galaxies raced past the Milky Way. According to project principal investigator Andrew Fox, the flash was so powerful that it lit up the stream like a Christmas tree. It was a cataclysmic event. This shows us that different regions of the galaxy are linked, but happens in the galactic center. But when it happens in the galactic center, makes a difference to what happens out in the Magellanic stream. We're learning about how the black hole impacts the galaxy and its environment. The ionized gas can't be directly seen. Instead, it was mapped out by taking spectra of the distant quasars and looking for absorption lines in the quasar light from the relatively nearby gas. Since every atom and every ionization state of every atom has a unique fingerprint of absorption or emission lines, the team was able to get not just the composition of the absorbing gas, but also its ionization state. This is a nice, clean result, and scientists are even able to figure out roughly when the high-energy flare occurred in our Milky Way. It turns out that had you been an early hominid on the Earth 3.5 to 2.5 million years ago, you would have seen the core of the galaxy shining in Sagittarius with a ghostly glow. This was a million-year-long event. This is one of the few times we know that a galaxy-shaping event would have been visible to the unaided eye. Thank you, Mythtown, for the bits. Thank you. Our Earth was unaffected by this particular event. But other worlds closer to the core of our galaxy may not have been so lucky. Once again, we're reminded it's all about location, location, location. One of the most energetic, potentially deadly, and still unexplained phenomena of our universe are fast radio bursts. These momentary bursts that, in a few rare instances, actually repeat, emit the same energy in seconds that our sun will release across 80 years. Part of understanding what they are requires just understanding where they are. New research from Australia's CSIRO has been able to catch 4 of these systems bursting and precisely identified their place on the sky. They appear to be in the outskirts of galaxies, ruling out supermassive black holes as the source. This work is published in the astrophysical journal Letters with lead author Shivani Bhandari. While this paper still doesn't tell us exactly what the source of these objects is, the location hints that it could be aged objects undergoing dramatic interactions, such as neutron stars or white dwarfs. More research is still needed, but this is a major step forward. From the distant universe, we now look closer to home. We have a pair of stories about the red planet. Using new dynamical models, scientists at the SETI Institute and Purdue University, led by Matija Cook, have found new evidence that Mars had small rings in the past and will likely have them again in the future. This is all part of a cyclic ring theory for Mars. As a stellar astronomer, I'm going to choose to quote from the press release on this because I can't find a better explanation than they've already provided. Here's what they wrote. Mars' inner moon, Phobos, is losing height as its tiny gravity is interacting with the looming Martian globe. Soon, in astronomical terms, Phobos' orbit will drop too low, and Mars' gravity will pull it apart to make a ring around the planet. Hasselbrock and Minton proposed that over billions of years, generations of Martian moons were destroyed into rings. Each time, the ring would then give rise to a new moon, smaller moon, to repeat the cycle over again. This cyclic Martian moon theory has one crucial element that makes Deimos' tilt possible. A newborn moon would move away from the ring in Mars, which is in the opposite direction from the inward spiral Phobos is experiencing due to its gravitational interactions with Mars. An outward migrating moon just outside the rings can encounter a so-called orbital resonance in which Deimos' orbit is 3 times that of the other moon. These orbital resonances are picky but predictable about the direction in which they are crossed. We can tell that only an outward moving moon could have strongly affected Deimos, which means that Mars must have had a ring pushing the inner moon outward. Cook and collaborators deduced that this moon may have been 20 times as massive as Phobos and may have been its grandparent, existing just over 3 billion years ago, which was followed by 2 more ring moon cycles, with the latest moon being Phobos. Now, we don't normally use that large a quote, but our hat is off to press release author Rebecca McDonald for that clear description that she has provided for media use. What is particularly nice about this result is that it has related compositional predictions. And if this theory is true, JAXA's future Phobos lander should be able to prove or disprove this published idea. You can read more about it in a future Astrophysical Journal Letters paper. Finally, we have 2 quick news notes. With a lot of help from the InSight shovel, the Mole thermal instrument has finally made its way into the ground on Mars. It's unknown if it will be able to bury itself any further, but it is at least now out of sight in the dirt. It's a start, people. It's a start. Also, a new CubeSat that was designed by the Jet Propulsion Lab to test just how much science you can pack into an orbital briefcase has been able to detect a known exoplanet orbiting 55 Cancri. This shows they can do high-quality pointing, get high-quality photometry, and all from something that was basically tossed off the International Space Station and into orbit. It's just cute. Sometimes science is just cute. And that's all we've got for today. This has been The Daily Space. I'm your host, Dr. Pamela Gay, and I wrote this episode using a very large quote from Rebecca McDonald at the SETI Institute that was provided for journalists to use. This episode will be engineered by Ali Pelfrey with web content put together by Beth Johnson. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We're here thanks to the generous contributions and volunteer efforts of people like you. Thank you, everything, for all you do to support us. And thank you, Adam, altogether. I think I even have a dog cam. Have the images been out of... God damn it. The images have been out of sync. That makes me sad. All right. But I think I have dog cam. Let me pull up dog cam. Dog cam needs. Did you hear that? Oh my goodness. Oh my goodness. Oh my goodness. Stop it. Hi, Eddie. Who let you down here? Come on, over here. Go, go. Hi, you're going to jump up, aren't you? There, go over there. Good boy. Thank you, Ed Thomas. Thank you. Thank you all for everything you do to support us. All right. Look at that feeding frenzy taking place. Everyone needs a feeding frenzy now and then. All right. So let's see what questions we have. I like the way Limp Rimble puts it. Come on into the Astro Circus. Be amazed by the Fermi bubbles. Thrilled to the periodic rings. See the egress. I am totally going to screen capture that because that is kind of awesome. Let's see what else we have in here. Thank you, Ed Thompson. Thank you. Yeah, I know, Pamela. I know, Paranor. I screwed up and cursed, but I was frustrated. Let's see. Hanny asks, do we know what size the CubeSat was? They said it was the size of a briefcase. So it was probably just a couple of feet by a couple of feet. It's super tiny. So Hanny asks, do we know if Deimos and Phobos are rubble piles or solid? They appear to be solid. They probably would have formed more like our moon out of stuff that came together with sufficient heat that it was able to form a single object. All right, what else is in here? I think that's all the questions up above. Scrolling back down to the bottom. Yes, Ed Thompson. Shiro eating pups or happy puffs. Let me see. So Malachi knows what this means. Do you want this? There you go. Oh man, I am getting bombarded with work messages off the side and I now need to make a phone call. I need to tie this up so that I can make a phone call. All right, I'm sorry to end this so abruptly. Work calls people and work doesn't always know what all is going on. And wow, I accidentally lost a button off the top of my screen. Roll credits. All right, so let's figure out who is out there to potentially raid. Gibson Pix is streaming during the day. I think that my screen simply hasn't updated from last night's who's available to raid. So let's fix that. So Prof Melko, we're going to raid Prof Melko, who, no, we're not. Prof Melko is covering C-SPAN. We're going to raid EJ because EJ is talking space. All right. Thank you, everyone. Once again, this has been The Daily Space. I am your host, Dr. Pamela Gay, and I wrote today's episode along with a big chunk of help from Rebecca McDonald, who provided a press release that was way better than anything I could have written. Today's episode will be engineered by Ali Pelfrey, and the web content and social media content will be produced by Beth Johnson. We are a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. Bye-bye, everyone.